This video supplements the current deployment status section of our iPoster. So specifically, we'll be going into spatial trends, both for onshore wind and solar PV energy deployment between the years of 2010 and 2019. So starting with onshore wind, we're just going to go from 2010 to 2019 pretty quickly, just so you can see where these deployments have been made over the last 10 years. And then we give you, again, a different type of snapshot to understand where we are with onshore wind turbine additions within this 10-year time frame. So in our key findings box, pause as you wish, but we show how many wind turbine deployments, specifically utility scale, so over 1 megawatt, that were deployed by year. Under this, we give you the total of deployments and areas in which there were the highest deployment rates or amounts by county. And then we end with 97% of the counties that deployed utility scale wind power plants between this time frame had wind energy as the county's cheapest form of technology. And here we measured this through the levelized cost of energy or electricity. And for these counties, it equated to be $75.39 per megawatt hour. And then on the right-hand side, we have a table of the counties that deployed wind turbines within this time frame, the amount of projects that they deployed, and the years in which they deployed these projects. So now we're going to be moving to solar photovoltaic additions. And we start here. Notice the time of 2016. This is when the first utility-scaled power plant relating to solar photovoltaic energy took place in Iowa. So we're going to just be moving from 2016 to 2019. And also note here that there were no deployments in 2018. So we have skipped that and have showed deployments in 2019 to give us an aggregated snapshot of the deployments between 2010 and 2019. Again, our key findings box are relatively the same, so pause it as you wish. But I'll also touch on all counties that deployed these power plants between 2010 and 2019 had wind energy as the county's cheapest form of technology. So essentially, these photovoltaic power plants are quote-unquote going against the grain, and this is what we kind of want to understand. Why are people deploying these solar photovoltaic power plants when the cheapest form of technology in this area was wind energy? And we saw the levelized cost of electricity or energy for these counties to be $82.10 per megawatt hour. So this, again, was higher than the average seen for onshore wind previously. We have a smaller box at the top because only 6 projects were deployed in this time frame. So then under it, we kind of want to understand, what did we see in this development? Was there anything specific we should touch on? So we saw that the average levelized cost of energy by cheapest technology source in Iowa is around $76.81 per megawatt hour. 5 of the 6 counties that deployed a power plant project relating to solar PV between this time frame had an average levelized cost of energy above the state's average. So looking at $82, it is obviously higher than $76. More specifically, 83% of the utility-scale solar photovoltaic power plant deployments resided in counties where their land cash rents in dollars per acre for a given year were lower than the state's average. And if you want to, manipulate the data into another perspective, 100% of power plants deployed after 2016 were in counties where these cash rents fell below the state's average. So these are just points we want to touch on in further research and understand why this is the case. Why are we deploying stuff in areas where cash rents fall below the state's average? And then finally, 50% of all utility-scale solar photovoltaic power plants deployed between 2010 and 2019 fell below the state's average, noted inflation-adjusted value per acre of Iowa farmland. Again, manipulating the data, we see that 75% of these power plants deployed after 2016 were in counties where the average value per acre of Iowa farmland fell below the state's average. So these are things we want to start learning more about and understanding why this is the case. Is this affecting deployment rates throughout every county in Iowa? These are just questions we want to start asking ourselves after we're finished with preliminary research. And then finally, I leave us with a consideration in deployment status in Iowa. So this is from the U.S. Atlas from the EIA. And we see that what is being shown on the map, these yellow and black circles, are indicating where an operable utility scale solar photovoltaic power plant resides. So we see Iowa near the middle bottom portion of this map, and then we have the surrounding states as well. So the shading of green indicates the solar resource in a given area, so a lighter shade of green indicates a higher solar resource. Why is this snapshot relevant to our research? Why did I include this? We want to see that we see like concentrations of utility scale solar PV projects across Iowa's statewide border in Minnesota and even in Wisconsin. We want to understand why this is the case. Why are there necessarily more utility scale solar PV projects in states above us with a lower solar resource? What's the case for this? Is it socioeconomic factors? Is it resource factors, which seem not to be the case based on the solar resource on this map? Or are there other factors we have yet to consider and that we need to focus more on? So, in all, we want to focus more research to understand the weights to which other factors could influence deployment rates of utility scale solar PV power plants in the coming future.